Hello there, Algebra B students. Today we're going to talk about section 11-1, which is on simplifying radical expressions. First, we need to know what a radical is. Below it says, write two examples of radicals or roots. Well, when I say roots, you might say the square root of 4. A root is a radical. Another example of a radical would be root 3. Now, when you wrote square root of 4, you probably were thinking, well, the square root of 4 is 2. 4 is a perfect square. So below it says, write 4 perfect squares and what are their roots. So, square root of 4. 4 is a perfect square. When we simplify that, that's 2. Square root of 9. That's a perfect square. When we simplify that, we get 3. Square root of 16. When we simplify that, we get 4. And 25 is another perfect square. And when we take the square root of that, we get 5. Let's take a look at our examples. The directions read, simplify the following using the two methods. I'm going to teach you two methods and you can use whichever one you're more comfortable with. One is called the perfect square method. The other one is called the prime factorization method. We just talked about perfect squares. What you're going to do is look for perfect squares that go into the radical number. So when I look at root 12, a perfect square that goes into that is 4. So I'm going to rewrite 12 as 4 times 3. Now you can break those apart. You can write root 4 times root 3. When you look at that, the square root of 4 is 2, and you can't do anything with the square root of 3, so you leave it alone. We have just simplified root 12. Let's take a look at our other method, prime factorization method. In this method, you have to make a factor tree, prime factorization. We talked about that a number of chapters ago. So when I make the factor tree of 12, it's 4 times 3, and break 4 down, which is 2, times 2. All right, now we rewrite that underneath our radical. 2 times 2 times 3. Two times 2 is really 2 squared. So I'm writing under that, under a radical. And then I have root 3. Now remember inverse operations. If I have 4x equals 12, you use the inverse operation to get x alone. You divide by 4. And then remember how the 4's cancel each other out? You use inverse operations so that they cancel each other out. Well, square root and square are inverse operations. So these two are going to cancel each other out. The root, or the radical, and the 2 will cancel each other out, leaving you with 2 root 3. Same answer we got earlier. Let's look at our second example. Root 18. What perfect square goes into 18? You're right, it is 9 times 2. Break it apart, root 9 times root 2. Square root of 9, 3, root 2. That's our answer. We can't simplify root 3. All right, let's try this one with the prime factorization. 18. 18 is 9 times 2. Now, as you're looking, you're going, well, this is kind of the same thing. I agree 100% with you on that. Just two different methods to do it. All right, write everything underneath the radical. You've got 3 times 3 times 2. 3 times 3 is 3 squared. Write that underneath the radical. And root 2. Again, square and square root are inverse operations, so they're going to cancel each other out. That's going to leave you with 3 root 2. And as I look back over here, I miswrote. This should be a 2. Three root 2 is our answer. So in some ways, it's kind of nice to do it two ways. Then you can double check your answer. Our last problem is 600. All right, right now you're going, oh boy, I don't know, 600. Well, 100 is 10 times 10. So I've got 100 times 6. Break it apart. Square root of 100, square root of 6. Square root of 100 is 10 root 6. Now always think about, can I do anything more with that radical? Can I simplify that root 6? That's 2 times 3. Not going to be able to. Final answer. All right, prime factorization, 600. You're saying 6 times 100. Not quite as user-friendly here. 2 and 3 for 6. 100, 10 and 10. Oop, I'm going to run out of room. 2 times 5. And 2 times 5. Okay, so this time I have to write it under my radical again. I'm going to have, how many 4? I got 1, 2, 3 2s, a 3, and 2 5s. All right, I'm looking for groups of 2. Oops, I don't want quite such a long. So I got 2 squared there. Here's another group. I got 5 squared. I got root 2 and I got root 3. So now, again, we've talked about this before. The square root and the square cancel each other out. So that leaves me with a 2, an integer. Square root and square cancel each other out, leaving me with 5. And then I've got root 2 and I've got root 3. 2 times 5 is 10. Just like when you broke them apart, you can put them back together now with radicals. So that makes root 6. So there's 2 methods. You can use the prime factorization method, which I just got done with, or you can use the perfect square method. And so, students, you have an awesome afternoon and evening, and complete the back side of this worksheet.